Hey guys, we're going to do a quick review of the types of compounds that we encounter the most. You have your metallic compounds, ionic, and covalent. On your metallic compounds, what's happening is you have your core, your nucleus of all your different atoms, sorry, I'm forgetting what I was going to say, and then floating around all of them is your electrons. And that's why it's called an electron seed model, because they don't travel around just one particular atom or neutron, or nucleus. They travel around all of them, and that's how they hold them together and making them malleable. That's where you can pound them into a sheet so they're easily adjusted. Ductile means you can pull it into a straight, thin wire. Because those electrons are moving around so much, that's why they conduct electricity. And of course, the metallic compounds have your highest melting point of the three types that we talk about. Then you have your ionic compounds. You have your positives and your negatives coming together to form a very tight, that should be a negative, bond, because you have so many positives and negatives, and how many we have and what charges we have we'll deal with later on in this unit. So you're going to have an ionic compound anytime you see metals with nonmetals, polyatomics, or anything. They do not conduct electricity by themselves. Salt doesn't conduct electricity, but you do have, when you dissolve them, it breaks apart those ions, and so you end up with your electrolytes or aqueous solutions, and you do have some electricity conducted there. And between the three types, it's the medium melting point. Okay. Covalent compounds are your nonmetals or metalloids together. They are sharing their electrons, and we'll talk about why in just one second. And we have polar and nonpolar, and I'll explain that, and lowest melting point of all. Regardless of what type of compound we are talking about, it's your valence electrons that cause everything to bond together. So how do we know that we have a polar compound, nonpolar compound, or ionic? Well, we use the electronegativity differences values to figure that out. When you look at your electronegativity values for your nonmetals, you can see that they're pretty close together, relatively close. How much difference they have is whether it's a polar or nonpolar compound. So then you have your metals. There's a huge difference between a metal and a nonmetal. That's why they end up having your ionic compounds form. So what I'm going to look at is we'll look at bonding with just fluorine to itself, and then a fluorine oxygen on the next slide to talk about what whether it's polar or nonpolar, and what does that look like. So when we're talking about a nonpolar compound, that's when they really don't have that much difference between them. So if you have two fluorine molecules together, your electronegativity difference is 0. That means that they're pretty much sharing the electrons around them, and that's what holds those two atoms together. When you have oxygen and fluorine, those electronegativity difference equals 0.5. What that means is fluorine is slightly stronger than oxygen, and so it pulls more of those electrons. The analogy that I used in class was when you have fluorine and fluorine together, they're equally strong, so in a tug-of-war match, one's not going to win over the other. But when you have oxygen and fluorine coming together, fluorine's a little stronger than oxygen, so it ends up pulling that rope of tug-of-war closer to them. Neither of them actually wins the rope, but you end up where fluorine is, where it's on fluorine's side more than on oxygen's side, because fluorine is slightly stronger than it. Then if you look at lithium and fluorine, they have an electronegativity difference of, I believe it was 3. What that means is fluorine is just so much stronger than lithium, it's going to just grab all of those electrons, or grab that valence electron, leaving lithium with a positive charge. So all of the valence electrons float around fluorine, and lithium is out there. You end up with those ionic solids because you have lots of fluorines around and lots of lithiums into structures that we're really not going to talk about in this unit. Okay, so when you're trying to figure out, is it a ionic or covalent compound? First, your ionic compounds is when you lose electrons, when there's a huge difference between them, and your covalent is sharing. If you have a compound that has any of these things that are in the blue, those are all your metals. Notice that metals take up most of the periodic table. All of those blue, you see one of those elements, it is an ionic compound. No ifs and buts about it. We don't really even pay attention to the difference in electronegativities. If you have compounds that are made up only of this upper right-hand corner, then you have a covalent compound, and that's where you have to look at your electronegativity values to see if it is a positive or a negative, or I'm sorry, a polar or nonpolar. Are they really close to each other, equally strong, or is there enough of a difference that one is slightly stronger than the other and you're going to have a polar compound? All right, see you in class.